So this is lab 2. We're gonna take in this lab some introduction about our microcontroller, the MSP432. Okay, and how to deal with the Launchpad and how to program it, basically, the principle of all of these. Okay. So these are the basic, specifications of MSP432. It's up to 48 megahertz frequency, clock frequency. And when I say up to, that means we can configure it to run at lower frequency. And that's very important in microcontroller application because power consumption is a concern usually. Because is a robot usually, when it moves by itself. It's not connected to anything. So reducing the power consumption is something, desirable all the time. And of course, the frequency usually of micro is very small compared to, for example, to your laptop processor frequency, which may be around 2 gigahertz or maybe more. But because this is a different domain of applications, okay, it's embedded application. The RAM, it's up to 64 kilobit RAM, and the flash memory is around quarter of a megabit. And that's mean when you load some programs, the program size has limitations. You cannot code any program and just dump it to the flash memory. The flash memory, by the way, is the memory that is used to load your program. When you write your program on Windows, for example, or whatever editor, like for example, it's a Composer Studio, and you load it to the microcontroller, it goes to the flash memory, okay? While the static RAM is used at runtime to create, if you create some variable or something, it's created there, okay? And when you update this variable, the update value goes to the RAM, okay, not the flash memory. So this is basically the MSP432 microcontroller. It's repeated in here on the Launchpad, okay. Yeah, so to program or to deal with our kit, we need 5 basic references, okay. The first one is the Launchpad user's guide, okay. Is the first page of the file. I sent you all these files, by the way. So this Launchpad user's guide contains the basic information about the Launchpad itself, the Launchpad kit, the small kit, not the whole kit, the small kit that has a microcontroller above it. Okay, it contains the schematic of this Launchpad, what are the peripherals that are there, for example, LEDs, buttons, switch buttons, okay, all such stuff, and how it's connected to the microcontroller is there, and also how the connection between the computer or the thing that will program the microcontroller is done. So we have also on the Launchpad some what's called debugger. So this debugger is or JTAG, whatever they call it. It's responsible for programming or receiving the program from the computer and load it to the microcontroller. The second important reference that we're gonna need is the data sheet of the microcontroller itself. Okay, in data sheet, as the name suggests here, it's pin and board functionality. So this data sheet, any feature or any functions that your microcontroller can do for you, okay, is related to some board or some pins on the microcontroller. So to know which pin to use for some particular functionality, we look at the data sheet of the microcontroller. The third important reference is technical reference manual, TRM, okay? So the technical reference manual is actually a programming guide, how to program, okay, the registers inside the microcontroller, or how to, you know, set up some functionality. Basically, we program this microcontroller has some registers in it. Okay, these registers are used to configure the functionality we want from the microcontroller. Okay, so this programming, this technical reference manual basically teaches you how to do that. Okay, or what configuration the registers need, so that you are, as a programmer, can apply some functionality on the microcontroller. The fourth reference we have is TIRSLK users, the kit itself, the whole kit, you know, the chassis. So this is a Launchpad. This is a small thing here. I know it's not that clear. So this is the Launchpad. Okay, this has a separate manual, or separate, manual user's guide. But the kit itself, okay, has another user's guide. And this user's guide is basically teaches you what's on the chassis board, all the sensors that you can use, okay, how to assemble or disassemble the kit itself, what is the interfaces between the kit and the Launchpad, or any Launchpad that can be, you know, connected to that basically to that kit, because we can apply, for example, you know, attach to it for some LCD, or you know, some other interfaces like a speaker, for example. So all such stuff is there, or this information that you're gonna need to know how to connect stuff is there in this user's guide. Okay, and finally, the driver library user's guide. So the driver library is something. It is basically the API. So when you program an embedded system like this, you will gonna need something more than what C or C++ can give you. Okay. For example, if we want to program some registers there, so each register inside this micro has some, you know, a keyword, we can say, that we can use, so that the compiler knows, okay, we wanna program such this is specific register. So for example, we have 8 registers out there. We can nominate, and we can, you know, choose one of them as P1, P2, B. So with this naming, which came from the driver library, basically we can, you know, point to some particular in our programming, some particular register. Okay. Any question? Okay. Today we're gonna, you know, explore, you know, some basic functionality of the microcontroller pins, which is the general purpose input-output ports. Okay, so as I said, we have, you know, many of these ports on the microcontroller in here. Okay, and we use basically these ports to, you know, to connect it to some as an interface to other ports or peripherals on the Launchpad, or even on the kit itself, the chassis board. Okay, we have, I'm sorry, 10 boards, not 8 like what I said. We have 10 boards on the microcontroller. Most of them are 8 pins. That's the confusion. So we have 10 boards, but each board has a 10 pin, for most of them. Okay, and as I said, we use these ports to connect to our preference. Okay, or to apply some functionality in the on the microcontroller, like for example, to connect it to the LEDs. So for example, we have here some LEDs. We have here some switch buttons on the Launchpad. So there are some particular pins on the microcontroller that are connected to these, you know, preference, the LEDs or these switch buttons on the either side of the Launchpad. There are some timers inside the microcontroller. So to use these timers, we need also some specific ports, and we need to program some pins in a specific way to apply such timers, as we will see in the future. We have also a UART, you know, serial port, we can say. Is that if, for example, if you want to send something on the run at runtime, okay, from your computer to the microcontroller, use such UART. Okay, and some other functionalities that we will explore in the future. So, as I said, we have 10 boards on the microcontroller. We have 10 pins. We have 10 UART. Okay, and some other functionalities that we will explore in the future. Okay, and some other functionalities that we will explore in the future. Okay. So basically, to increase the functionality of the microcontroller and also reduce its form factor or size, we can each board can serve multiple functions. Okay, and according to your programming or your configuration, your setup in the program, you're gonna choose one of these functions. Okay, so for example here, board 2, okay, can serve as a general purpose input output board. Okay, so you can use these pins to insert a signal or input signal to the, as an input signal, for example, to receive input signal to the microcontroller, or to output some signal from the microcontroller to outside world. Okay, and also it can be used as a timer, so especially the first 4 bits. So for example, pin 2.7 can be used as a general purpose input output pin, so you can receive signal or send a signal through that pin, and it can be also part of the timer, so you can use these 4 bits as a timer value, for example. And how we differentiate between them in the configuration. So there are some registers inside the microcontroller. You will set up or put some values in these registers to tell the microcontroller what you wanna use pin 2.7 exactly. Is it a timer, part of the timer, or as a general purpose input output pin? Okay. So basically, as we see here, each pin has, can serve with many functionalities. Okay. So for example, we have, this has 2 functions. Some others has 3 functions or maybe 4 functions. Okay. So we refer to this function as GPIO. So this is the default, we can say. Also, it's not that default, but yeah, we can say it's a default. Okay. It's a default function as a GPIO, general purpose input output. The second function called the primary function. Why they didn't call the first one primary, that's not my problem. This is their problem, TI problem. So we have the first function is called the GPIO function. If the board or the bin can serve 2 functions, the second one called the primary. If it can serve 3 functions, the third one is called secondary. If even, but this is the maximum here in this for this microcontroller. The fourth one is called tertiary function. Okay, so we start from GPIO. This is a default, we can say, and in general, the bin can serve up to 4 functions: GPIO, primary function, secondary function, and tertiary function. Okay. Maybe some bins like 2.7 has only 2, so we have GPIO and only primary. That's it. Okay. Now, how to configure each bin to some specific function, either the GPIO, primary, or secondary, or tertiary. Since there are up to 4 functions, okay, for any bit in general, we need 2 bits, we can say. Okay, so we have for each board, there is 2 specific registers for each board. So for example, for board 2, there are 2 registers. One is called B2 cell 0, selection 0, and the other is called B2 selection 1. Okay, if you wanna, for example, choose the GPIO function for or modify bit 4 in that register, B2 3 means port 2 or bin 2, bin of port 2, bin 3 of port 2, yeah, or port 2 bin 3. We can say in any way. B2.3 means port 2 bin 3. So we choose the functionality of such bin, for example, by configuring or set up these 2 registers. Which bit in these registers? Bit number 3, or the 4th bit, okay? Because we start from 0. So each one of these registers is 8 bits, and we will choose our function, okay, by configuring the third bit, I'm sorry, bit number 3 or the fourth bit, okay, 0, 1, 2, 3. So for example, the GPIO is 0, 0. So if you put 0 and 0 here, 0 in this bit and 0 in this bit, then you are setting B2.3 as a GPIO bin, okay? If you wanna, it's a primary function, whatever it is, for example, a timer or UART or whatever, okay? Then you look at the data sheet, and from the data sheet, you will know what kind of setup is corresponding to the functionality you want. For example, maybe B2.7 or B2.3 in that case can serve as a UART, for example. And this UART, for example, is a secondary function. Secondary function, so 0, 0, 0, 1, this is 1, 0. Okay, so based on this combination, you set up the functionality of the bit. Again, as I said, to know the functionality of each bit, we look at the to know what exactly we're gonna what values for BXSL for any board. We look at the technical reference manual because this is a programming manual. So here, for example, this is a general. So 0, 0 is the general GPIO, 0, 1 is the primary, 1, 0 is the secondary, 1, 1 is the tertiary, the final one. Okay, so for example, for port 2.0, this means the first bit in port 2. Okay, this first bit can serve as with 4 functions, whatever these functions is. So 0, 0 is a GPIO, look, IO, input output. Whatever this function is, if you want this function, you should register. You should put 0, 1 in BXSL registers. If you want this function, you put 1, 0. If you want this function, you put 1, 1. It's basically this bit has only 2 functions because these are don't occurs. Okay, so here we have only 2 functions. Okay, so basically what I want to say, for each board there are 2 registers called selection registers. Okay, and we call this in general as BXSL1 and BXSL0. BX is actually the port number. So for example, for port 1, this will be B1 cell 1, B1 cell 0. Port 2, B2 cell 1, B2 cell 0, and so on and so forth, until B10 cell 1 and B10 cell 0, because we have 10 ports. Okay, and basically based on the value inside these 2 registers for each bit, you configure some functionality. Let's start by the general purpose input output functionality, which all the ports can serve. Okay, if you choose a bit to serve as a general purpose input output, it would be an input bit or output bit. Okay, if it's input bin, then it will receive external signal, or you will read external signal through this bin. Like for example, if button was pressed, this would be converted into a signal, and through the signal you would know if the button is switched on or off, or it's pressed or not pressed. If you have a sensor that is connected to your robot or microcontroller, then this sensor will sense something and convert it into an electrical signal. So you should have or configure some bin to read the signal to know what is the reading of the sensor. On the other hand, if you have an output bin, then the microcontroller will use this bin to to drive something, to output some signal, to give some signal out to the environment or the robot itself. Okay, or and this signal can be used to control some peripheral or even a sensor. That's fine, or the motor, for example. Okay, so you know, a simple example for this or simple application is to turn on or off a motor or control a motor, turn on or off LED or whatever, something like this. When you choose the general purpose input output functionality for some board, we need to define the direction of the pin, if it's input or output. So again, for each board, we have another register, a third one now, okay, called direction register. So for example, for port 2, we have B2 dire or direction, okay? If you want to set pins 3 and 5 or pin 4th, the fourth pin or number 3, and the sixth pin or number 5, okay, as an output, through the configuration of direction register, you will set that. 0 is used to input, and 1 is used for output. So for example, if B2, if you want to configure pin 5 of port 2 as output, you put 1, I'm sorry, you put 0, I'm sorry. Ah, this should be flipped. I'm very sorry for this. So this should be the opposite. This should be 1, and this should be 0. Okay, so you put here 1. This means this pin is as output pin. So the microcontroller will send signals through this pin to the outside. And B2.3, the fourth pin or pin number 3, here is 0, it's input, so we put here 0. So the microcontroller will receive signals through that pin, for example, from a sensor. Okay. Today we're gonna apply very, 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 very simple application to our robot, okay? Which what we have done previously, by the way, the last lab, okay? Which is, you know, turning on and off a LED. But this is a very good example because it's very simple. Once you understand it, you will be understanding the basic concept, so you can apply something by yourself afterwards. Okay. Basically, on the Launchpad, we have we have many LEDs actually. There are more than 2, but we have here what we considered in this lab, LED 1 and LED 2. Today we're gonna control LED 1, and your assignment will be LED 2. Okay. If you remember last lab, there were 2 LEDs that are blinking. One was red, the other was cyan. Okay. Actually, the other one, LED 2, is, you know, is more interesting because you can change the color of this LED. It's not only red or no cyan. You can have many colors actually. Okay. But today in this lecture, I'm gonna give you the code to control LED 1. This one here, LED 1. This is LED 2. Okay. So let's see how to do that. So basically, if we revise or review the Launchpad user's guide, I'm showing you how to use references now. Okay. So in the Launchpad user's guide, if you look at the schematic, because there are LED, okay, there are some LEDs out there, but we need to know this LED in particular, LED 1, how it's connected to the microcontroller, our microcontroller. So if you look at the schematic, LED 1 here is connected to, so this is a microcontroller basically, and our LED is connected to port 1. Dot 0 means the first pin or pin number 0. Okay, so this pin so we have here eight pins, and our LED is connected to the first one of these 8 pins, or number 0, we can say. Okay, so if so we need now to configure or set up this pin as an input, as an output pin, I'm sorry, as an output pin, GPIO as output, and then in the program we're gonna send 1 to turn the lid on, or 0 to turn the lid off. Okay. A second one, the second step now, how to configure the registers inside the microcontroller to know, to apply such functionality for port 1. Port 1.0, because we want the first bin. We are interested in the first bin only. Okay. Then we look at the data sheet. For that particular, application, we can look at the data sheet and also or the technical reference manual, because they will provide you enough information. For more sophisticated examples or applications, you may need also the technical reference manual. Okay. So if we look at the data sheet of MSP432, okay, you say that the input-output functionality of port 1.0, okay, you should put 0 and 0 in the first bit of B1 cell 1 and B1 cell 0. Okay. And 1 means, I'm sorry, 0 means the input and 1 means the output. Yeah, that's what I said here. Yeah. So B2, this was output, so 1, yes. And B2.3 was input, so 0, yes. Okay. So in the direction register, if you put 1 at the first bit, then you are configuring B1.0 as output. If you put 0, you will configure this bin number 0 as input. Okay. Okay, so this is the second step. The third step, yeah, as I said, the technical reference manual will give you the instructions in themselves, okay, how to write, what would be the code. So we know the value from the technical reference, from the data sheet, okay, but the coding itself came from the technical reference manual. Although it's not that clear or direct in the technical reference manual, but this should be, I mean, I didn't learn this from technical reference manual. How to write this as a code in C++ or C. I learned it actually from other sources, okay? For example, the book that I shared you in our first lecture, I told you about some book, okay, that we're gonna use in that part of the course, okay? But anyways, it should be, the technical reference manual for any micro should be used for that, but it's not really, it's not really, clear in our microcontroller for such particular job to know how to program this microcontroller. But anyways, if you wanna do this configuration, you should write these 3 lines of code. Although there are some, some variations. That's why I'm saying it's not that clear. There are some, but it should be the same. I mean, something similar, as you will see. And the second step is to control. So these are the configuration step, okay? By setting these 2 bits in the cell 0 register and cell 1 register of port 1 as 00, you are setting up this bin as general purpose input output. To set it as output bin, we put here, but yes, there should be 0.0 as well, because direction register is also has 8 bits, okay? So we should configure only the first bit with 1. That means bin 0 of the port 1 will be set as output bin. Now to send 0 or 1, we write such something similar to this. B1. There are a 4th register called the output register. So this is 2 registers, cell 0 and cell 1, direction register. And there is another register called the output register, in which if you want to send, for example, 0 or 1 to bin 0, you put 0 or 1 in the first bit of this output register. Okay. Then something inside the microcontroller will take this value and put it on the on pin 0. Okay, guys, and here is the code again. That's very simple one. Again, there are variations. It's not exactly like this coding. There are some variations. Okay, so let's learn how this. So first, you should include the driver lib. Okay, why you should include driver lib? Because there is nothing called the B1 in C++ or C. So the compiler will know how to translate this based on the driver library. Okay, so this means port 1 direction register, okay, equal to 1. So here I am putting 1 in this direction register. What does that mean? That means this 8-bit, I will write 1 in the 8-bit of direction register. So it will be 1 0 0 0 0 0 0 0. 1 and 7 zeros beside. Then I will configure the selection registers. So the GPIO means 0 0. I should put 0 in the first bit. If you send just 0, then it will be cleared. So it will be 0 0 0 0, 4 zeros, then another 4 zeros. Okay, so all the 8 bits of these two registers will be zeros, and that's fine until this moment, because we have no complicated code. If you have a complicated code, you need to register to change only the first bit in either the selection register 0 or selection register 1, or even the direction register, because we are concerned only with the first bit or the first bin of port 1. Then you initialize the LED, so you output 0, just turn off in the beginning. That means, so here we are setting up the output register as 0. So we put 0 on pin 0 basically, but this based on that code here, we are putting zeros on all pins. Okay, although we only need the first one of them. We will learn in the future how to only target one of the pins, not all of them. Okay, and here is the running. So we initialize some variable, and this is the code that we saw last time. We have an infinite loop, and each time we increment I by 10 until it reaches some values, and we go into this loop here. Then in that loop, since we need a blinking for the LED, we need to XOR the previous value with 1. So for example, or 0, by the way, 0 or 1. We can say here B1 out XOR its original value and 1, or XOR its original value and 0. Both are equivalent. So basically here you are saying that so for example, if the current value is 0, so 0, which means turn off the LED. 0 XOR 1 is 1, so you will turn it on. Okay, so now B1 out has 1, and I will be reset, and we go back and increment I until we reach this value, and we go again in that to that line. B out equal to B out XOR 1. What is B out now? B out now is 1, and 1 XOR 1 is 0. So you will turn off the LED again. So you are blinking the LED. Okay. You guys can understand why I'm using here XOR or not?
Are you using XOR?
Johnny, you understand?
I don't understand.
Johnny Boulders, you have any problem with that? You understand that such line in the code?
Could you explain why we use XOR?
Okay, looks like, yeah.
He didn't understand why we're using XOR.
Yeah, you are off. Let's unmute it. Okay, so Johnny has a problem with this. Let's go to the tablet. You guys can see my tablet?
I think so. There we go.
Yeah, you should be seeing it. You see the tablet?
Yeah, I can see it.
Yeah.
Okay. So what I'm saying is something like this. So we have here the microcontroller. Okay, this is port 1. Okay. And this point pin 0 is connected to our LED. There are some resistance, you know, in the board, but that's not our concern. Okay. So to turn on the LED, we need 1. To blink the LED, I'm sorry, to blink the LED, we need to send 1. So the LED will emit light. Then we send 0, so it will turn off. Then we send 1, so it will turn on again. So we see that blink. Okay, good. So we need to send 1, 0, 1, 0, 1, 0, 1, 0, and so on. We can do that in a very simple, but it will take, you know, maybe 4 lines of code. But we can do that in 1 line of code. So basically, we can do that as follows: if B1 out, yeah, B1 out equal to 0, so B1 out equal 1. Else, we can do it in that way. Okay, that's very direct. I know that, but I was intentionally doing that way with XOR because it should be easier, and we will use that more in the future. So let's do. So this is one. This is solution 1, we can say. Now let's see another one, or another way to do it. Solution 2. We can say B1 out equal to B1 out, the previous value of B1 out, XOR, this is not C, by the way, I'm just writing it down, but in C we should do it in that way. XOR 1 or XOR 0, doesn't matter, that's fine. Okay, let's assume that B1 is currently equal to 1. So 1 XOR 1 is equal to 0. So when we reach that line and B1 is 1, then the new value of B1 out will be 0. So we'll turn off the LED. Okay? Then I will be increased like the code and so on until we reach this value of 1,000,010. Then we will execute that line again. But now B out is 0. And again XOR 1. 0 XOR 1 is 1. So XOR, actually, if you just count the number of ones. So if the number of ones is even, the output is 0. If the number of ones is odd, the output would be 1. Now, B1 out is 0. Then we go again in the loop. I will increment by 10 each time. Then we go again and execute that line. But now it's equal to 1. So 1 XOR 1 is 0. So we have here 0, 1, 0, 1, so on. Okay, that's what we exactly want. So we can do this with 4 lines of code or just 1 line of code. Is it clear now?
Hey, Professor, would it be possible to do P1?
Johnny, is it clear? Somebody answer me. Okay.
Hey, Professor.
Okay, guys, so that's why we use XOR. Okay, and yeah, the way I'm writing this line of code, you can write it in that way: B1 out equal to B1 out XOR 1 or XOR 0, as we said, or you can write it in that way: B. This is equivalent to that sign here means take what's on the left hand side and do XOR with what's on the right hand side. So it's basically the same. Okay. So this is just like if you remember, guys, like X, that means X equal to X plus 1. It's exactly the same. Okay, but with XOR, not plus. Okay, guys, so that's what we have.
Professor.
Okay, let me, yeah. And now we're gonna, see the code and implement it basically on our kit.
Hey, Professor.
Yeah, this is Composer Studio. Good. Here is just the same code in Composer Studio. Okay. And I should connect it to the, yeah. Good. And just. Okay, guys, so here is the kit, my kit. Okay. And yes, any problem, guys?
Professor? No, you can't.
Oops. You guys are all muted.
Professor.
So,
So
yeah,
this
there is a problem. I can't hear you. So it was not Johnny's problem, actually. So let me try to fix this. Hello? Can somebody talk now? Speak?
Hello?
Professor?
Hello?
Yes. Yeah,
Okay.
yeah, I can hear. So it was my problem, actually. Okay, if anybody has a question, guys? Any question?
Yeah, Professor, can you go back to the code you were showing us earlier with the XOR? I just wanted to see it real quick.
The tablet?
No,
Or
not the.
what?
I wasn't sure what it was on, but I saw that you were showing us the actual code that you wrote for this XOR.
Ah, yeah, on the tablet. Yeah.
Yes.
Let me show.
yeah.
Yeah, this one?
Oh no, the so before this, the actual code for it, not the explanation.
Code from the PowerPoint.
Oh,
Yeah, the
okay.
PowerPoint.
Yeah, this one?
Yeah, that one.
Yeah, what's
So for that, is it just when do you break out of this while loop?
there is no breakout.
There's no
So
breakout at all?
yeah. So basically the default, the default programs for any embedded system is that it should run, all the time. you know, forever until you turn off, for example, the power or whatever. Okay, so basically, usually embedded codes are not how can I say, turn off. Usually the turn off come from outside. A switch, for example, you know, switch off the power, something like this.
So then
So
that means all of our coding for this
will be-
robotics will be in a while loop.
Yes, that's
Okay.
right.
Got it.
Yeah. Okay. Any other question, guys?
And Professor,
Yes.
with the int I equals 10, does it always have to be 10, or can it just be any
No,
variable
you can
number?
just can put one. That's fine.
Okay, okay.
It's
Thank
a
you.
way. So this is, you know, a very, you know, a very primary way to do a delay. What we want is delay, right? A delay between. So the lid will become on for some time, then off for some time, and so on. Okay. So this is one way to do the delay, but it's a very bad way. In the future, we're gonna, you know, learn timers, and we're gonna set this to exact time. Like, for example, 1 second on, 1 second off, you know, something like this.
Okay, thanks, Professor.
Any other question? Okay, so let's, you know, let's run this. Yeah, so my code has finished. Okay, now I'm just showing when I run. I think there is a breakpoint. We're gonna see now. There is no breakpoint. Yeah, you see the blinking, guys? There is no breakpoints. So here is the blinking. I hope you can see very smallly.
Yeah, I can
Okay.
see it.
So yeah, this should be the output, okay, of when you apply the program. Let's for example, you know, put a breakpoint. There is a breakpoint, so let me activate it. Oh, there is a problem with it. That's fine. Good. So I see. Yeah. So now look, we stopped at the breakpoint. So the program is halted. So the output is just the output. The last output is 1. Before that, before we, you know, do that line. So when we execute that line, so you see, guys, it's red here, but it's not that clear because the launchpad itself is red. But anyways, when I go forward, let me see. Now we have some problem because yeah. Oh, okay. The USB was not that, you know, connected very well to the. So let me do it again. So the USB was not just disconnected, so that's why our controls was not activated. Okay, so we have the breakpoint, and let's, you know, disable it for a while. So it's blinking now. It's reactivated. Okay, so you see, guys, it's currently on. Yeah. Okay, now when we go forward, yes, it's turn it off. Okay, now let's see the variables we have. So this is I, now it's 1,000,010. After this line, it will be just 10. So let's see what's gonna happen. I don't know why it's not it's not responding from the first time, from the first click. But anyways, so now we now execute this line. So I become 10. And when there is some change, it's a change, you know, is marked in yellow. Okay. Now let's check the registers. Okay, let's do it again from the beginning. I will just, you know, yeah, just run it again. And I will put breakpoint here to see how the registers are configured. Okay. So yeah. So let's put a breakpoint here. And let's check the registers. So this is register B1. B1. Oh, let's see. Okay, so look, guys, this is the out register. This is the in register. When you read something, if you configure the bin as input and you read something, it will go to this register. Okay, this is the out register. This is the direction register. This is a selection 0 and selection 1 register. Okay, there are some other registers like what you see here, but we're gonna use some of them in the future, not all of them. So let's step by step. Let's see. So let's look at the direction register here. Okay, it's currently 0. Let's see what's gonna happen when we go. Boom. Look, guys, it's 1 now. Okay, it's a change. So this is not a variable. Like no, this is a register. This is a real hardware inside the microcontroller, and we are, storing 1 or writing 1 to this register. Then these are the selection registers. There will be no change here because basically they are 0 zeros in the beginning, and we are writing again 0. So there will be no change for this. Okay. How about the out register? It's currently 0, so we will not see also, but we will see the change using that line here. So it's 0
Professor,
now. Yes.
a question. So these pins, because I've worked with Arduino, are they already set for the different lights, or do we have to set those pins for a specific LED?
What do you mean by lights?
So, or my bad, the LED that we want to blink, right? Are they already connected to those specific pin numbers?
Yes.
Like hard connected, or do we have to connect them
Yes, hard
ourselves?
connected.
Okay, got it.
Yeah, and we know that from the Launchpad users guide. So let's read it. Yeah, here is the Launchpad users guide. Let's. Somewhere here. Yeah, this is basically the what we have, what I showed you in the slides. Okay, so here LED 1 is connected to B1.0 or port 1 bin 0. Okay, and there is even more. Yeah, this is just a specific schematic, just for some of the peripherals we have, like the LEDs. Here is, here is how this output bin is connected to the. This is a LED. There are some resistance, and here is the ground. I don't know what is this. I think it's a kind of jumper or something, but it's hard coded, so don't worry. And the schematic the micro should be in here. So it goes 1 or 0, then you turn on or off the LED. And here is LED 2 schematic. This is your assignment. Okay, this will be your assignment. So you should look at this figure here, okay, to know how to control the color, basically, of the second LED. Okay, actually the second LED is not only a single LED. It's three LEDs. Okay, one is red, the other is green, and the third is blue. So based on which one of them is on, you will see different color, because basically you guys know that RGB, any color can be constructed using red, green, and blue. Okay. So yeah, so we're gonna know you can control the color of the LED of this LED 2 based on which one is high or which one is low. This will be your assignment. Okay. So let's see how this out. Yes, yes.
I have a question for line 13. You're sending,
This one.
yeah, you're
Mhm.
sending 0 to pin 0 port 1, right? Is that
Yes.
what? So when you
Here,
run,
here you are sending 0 to the whole register. So the whole register, the 8 bits will be zeros. But since we are not using this is the other 7, you know, we don't care. What we care is that if bin 1, bin 0, I'm sorry, or the first bin is really have 0 or not. That's what we care about. Here we set it to 0, and also as a collateral damage, we are setting also the other 7 bits as zeros. Mhm. You understand or?
So is it not initially set to 0?
Whatever the initial value is.
Okay, so is that value random then, or is
It may
it's
be
not
random, yeah, it may be random, yeah. You never
okay.
know. You never know. You should all the time check from here. What was the value out there? If you don't want to mess with the other 7 bits, okay, you should do something that I will, you know, that we're gonna know maybe within this week or the next week. But we will know how to do that, how to only send 0 or set 0 at the first bit and without affecting the other 7 bits.
so in this case, you're setting the first bit, which is bit 0 to 0, right?
Yes, and all other bits as well. So basically, so let's write this down. B1 out. After this line will be something like this. I like to differentiate between the 4 bits, okay? So this is what we care about, this first bit.
Right.
Although this line has set all of them to 0, but we don't care in that application. Okay, so our program is, you know, is simple. We only we're gonna use only the first bit, so we don't care. There is no problem of setting other bits at the same time to 0. But we have a way to leave these as they were, whatever ones or zeros, and only set this one to 0 or 1, whatever you want. Okay.
So if you were to set that equal to 1, that would change the bit 0 to 1, right?
If you want, let's see, if you put 1 here, okay, this will be like this, exactly like this.
Right. Mm-hmm.
Because you're gonna convert to 1, or you're gonna write 1 as a 8-bit number. 1 as 8-bit number is just 1 and 7 zeros on the left. Okay. And if you want to write 0 as a binary number of 8 bits, it will be 0 and 7 zeros on the left as well.
So Professor, this is just basically binary or whatever digit it is. You just put like 13 if you want specific ones
Yeah,
on specific spots.
whatever number you put here, okay, this will be a decimal number. Then it will be converted to something in binary.
Okay.
So you wanna be sure that this binary have here 0 or 1 based on your requirement. Okay. You got me or not?
I get it. And then when you run line 24, because like in that case it's equal to 1.
No, it's not equal to yeah, with that case here.
Yeah, in that case it's gonna be 1
0.
XOR 1,
1,
which is equal to
0.
0.
That's right. Yes.
Okay.
Then, but now it has 0. When we go again to execute this line, it will be 0 XOR 1. It will be 1.
Right.
So we are toggling, like
Right.
what I'm saying, toggle.
Okay.
0 1 0 1 is just a toggling. Okay, this is toggling operation. You guys got it?
Yeah.
Okay. So let's continue. So let's see. Okay, now we are here. B out is 0 right now. So when we do this, yeah, become 1. Okay, now let's, yeah, now it's 1. When we XOR with 1, it will be 0. Now we are 0. When we go and XOR by 1, 0 XOR 1 is 1. So, oh, sorry. 0 XOR 1, yeah, 0 XOR 1 is 1. It's 1. Okay. And, you know, just continue with this. So, guys, write down this code. Okay. And your homework will be very similar. It will be to control LED 2. So you need to know which pin is connected to LED 2 from the micro, which pins. Okay, actually it will be 3 pins. And I will ask you to for a series of colors, because LED 2 is actually 3 LEDs. Let's go to the schematic and to make it clear for you. So your assignment will be about LED 2, this one here, okay? As you see, LED 2 is actually not one LED. There are 3 LEDs together in the same package, we can say something like this, okay? And they are connected to pin 2.0, pin 2.1, and pin 2.2. So board 2, pin 0, and pin 1, and pin 2, okay? Each one of these LEDs has its own color. Red, green, and blue. So based on voltages we have here, or what output we have here, 1 or 0, some of them will be on, some of them will be off. So you will see different color. So for example, if you send 1 0 0, you will see red. If you send 0 1 0, you will see green. If you send 0 0 1, you will see blue. If you send 1 0 1, you will see something different from red and the blue. If you send 1 1 0, you will see brown, I think. I don't know. Something different from red and the green, and so on. Okay, so that's how we can generate new color out of the colors that we
Wait,
have.
Professor, so do we convert the hexadecimal value of color into decimal to get the specific color that we want? Is that what you're...
No, not a specific. Let me assume I asked you to output 4 colors. Okay,
Yeah.
so let's go to the tablet and to explain this.
Because I get
Yeah.
what you mean by like getting the colors to show, but let's say you wanted like purple, right?
Mm-hmm.
So could I just put like the decimal value or hexadecimal converted to decimal value of purple, and then it would just automatically light up the necessary colors to make purple? Could it do that, or do you need to specifically tell which different color combinations need to go
I
off?
understand. Yeah, you can do that. You can do that in just one line. Yeah.
Okay.
So basically, we have B. We want to set 3 bits from B2.0, B2.1, B2.2. So let's assume this is the register. This is B2. Okay. This is B2.0. 0, 1, 2, 3, 4. Okay, so you are concerned with these 3 bits. You can configure on 3 lines. So for example, we want brown. Let's assume this is maybe wrong, but brown maybe is green and green plus red. I don't know. I assume so. Okay. So the blue, this is blue. This is green. This is red. So you want to send 1, 1, 0. You can do that on 3 different lines, setting that one, then that one, then that one, or on 1 line, which is basic 3. This is 3, right? 1, 1. When you convert that into an 8-bit binary number, it will be something like this. Exactly what you want. So basically you will have something like, so we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Okay, you have these 8, and you don't need hexa. You can just use decimals. That's fine. Okay. So basically, see what is the equivalent decimal number of these 3 numbers, and see and check your color, the required color, and just send that number to using this line, and that's it. Okay. But there will be no XOR, okay, because based on the color that you want, okay, you gonna send another number, okay, in B out, B2 out here, B2. I'm sorry, not B1, B2. Okay, guys, is it clear?
Yes, thank you.
Okay, can you please do that? Okay. I mean, apply this. Run this code. Okay, next time you have the code already, so just run it. It will be easy. Okay, but if you, of course, have some problem, just let me know. I can help. But next time I will not give you the code. You should write it line by line, because when you write something by yourself, it's just a training for your, actual implementation. So you will know what kind of problem you may, encounter without copying and pasting each time. So yeah.
Professor.
Yes.
So for the reference guide, did you post that on Canvas, or do we just look it up online?
What's the reference? What?
The reference guide that you referred to that has the schematics?
Everything on Canvas. Everything is on. I send it when I send lab 1, I think, in some announcement.
I don't think.
If you didn't, I can send
No,
them again.
I received those, but not the one that you're like referring to. Like right now, it's different. I don't know.
I think I did this was last, but I can send them again. That's fine. Don't worry about that.
Okay.
Just do that code right now, and let's have your LED is blinking. Then you are set to go. That's fine. We'll finish very early today. Okay.
Did that be finished by today or next week?
Yeah.
Monday?
You're gonna finish this today, but you have the assignment. If you wanna do it today, but I didn't publish it. I will publish it now. I will prepare it now. It's really easy. Okay. If you wanna complete it today, that's fine. Of course, that will be very nice. If you wanna do it, after the lab, tomorrow, whatever, it's your choice. But there is a deadline, of course. Okay, so guys, do that right now. When you finish, just show me that your LED is blinking. Then you are good to go. When you finish, just turn on your camera, show me that the LED is blinking, and that's it. Johnny, did you construct or assemble the kit?
Yes, I did.
Yeah, so please run the, you did it already. Just show me to verify, because I gave you the 5 points just for nothing.
Oh,
Just show
okay.
me.
Yeah, I'll show you.
When you finish, no, not now. When you finish your this code,
Okay.
okay, show me everything. So
Do we just
Gustavo,
have-
Gustavo, Gustavo Raya. Gustavo, I don't know. Saul, you have the same problem, right, with the new one? Saul,
Yeah, correct.
I don't know. I'm gonna talk today to Henry, and I'm gonna see. Okay.
Okay. Okay, thank you.
Mr. Mustafa, are you able to
Yes.
provide the code, or do we have to type it out?
This code?
Yeah, the complete program on the PowerPoint. Do we have to type it out, or
Type it out. It will be
Okay.
better for you.
Here, I ran it.
But
Yeah.
okay. Thank you.
Yep. Thank
Thank
you.
you. You can go. If you wanna stay, that's fine.
You have a good day, Professor.
Thank you.
Mr. Mustafa,
Yes.
how do you add the driver lib folder again to like the new
Yeah.
project?
Okay. So basically, I assume you have the first one, right? So look at my screen. I assume you have the first one. Okay. So you can, this is a very nice trick. Just
I don't
copy.
think I see your
What?
screen. Like I can't see what you're doing.
Yeah, your screen I think shows the grades or something.
Yeah, you're showing grades on your screen right now.
Oh, there we go.
You see this now, huh?
Yes.
Good. So basically, but yeah. So I assume you have this from the first time.
Yes.
Okay.
Mhm.
So just copy, and then here paste. Okay. Then it will appear like this. Okay.
Okay.
Then you go to this guy, properties, include options, new, workspace, and this guy, which is the second one, and driver lib. Okay, and that's it. Okay, then okay again, then apply and close. Okay.
Okay. Let me try that, and then I'll tell you how that goes.
Okay. So whenever you finish, let me know, because there is a grade for this. So this from here, from now on, if every lab we have, you should be online with me. Okay, there is no absence on that, and there will be a grade for just this, you know. Okay, Mark, you can go. Thank you.
Is it bad that I may have like 2 driver lib folders? Am I able to share my screen? I think you're on mute, Mr. Mustafa.
I don't know. Let me. I think you can have both, because it's just a folder, and that's fine. But you should refer to one of them. Okay. I don't know what's gonna happen if you refer to two of them.
Oh,
I think it will be bad. Just refer to one of them. Share your screen. Let me see what you have.
could you allow me to screen share?
You are allowed now.
Can you see what I'm looking at? The folder selection or no?
That's fine. Okay, I understand now. So that's fine. You can just target this MSP432. Yeah, just click there. Then, yeah, that's fine. Yeah,
Oh,
that
okay.
way that's fine.
Because
Okay,
there were
again.
2 driver lib folders, and I didn't know if that was gonna mess it up or something. I don't
No,
even
that's
know why it had to, but
okay. Okay. Because when you extract or unzip the folder, that is the zip file, you unzip it to a folder called driver lib. So, and this the file contains already a folder called driver lib. So that's why you have 2 of them. Okay, just click OK, and that's it. Apply and close. Yeah.
Okay.
Professor.
Yes. Yes.
Can I share my the robot, the blinking light?
Yeah, you can see. Yeah.
I don't know. Let's see.
Yeah, thank you very much. Thank you. Thank you, Chris.
Professor, I'm also sharing mine right now.
Just give me a second.
Yeah.
Christopher Bernardo.
Yes.
Okay, you're good to go.
Thank you.
Professor?
Yeah.
My-
Okay,
my
sir.
vote.
Okay. Thank you.
Professor, could I get some help?
Yeah, of course.
I'm having trouble running the code. I wrote it down and everything, but I don't know if it's the way I
Share your screen. Share your screen.
Can I share my screen?
Of course. Just click on the errors.
On which arrows?
Any one of the errors. You have 4 errors. Errors 4 items. Bottom
Oh,
right.
okay.
Yeah. They are just disappeared now.
Yeah, they
Run again. That's fine. Hit the hammer again. Yeah. It's all right. It's correct.
but my lights aren't blinking.
Now hit the debug. or you know this insect, yeah, but the bug, yeah.
Yeah.
Oh yeah, click yes. Click yes. Mm-hmm. Hit again the green button. The green. Hit the, yeah, this guy.
Oh, okay.
Should be blinking, right?
Good work. Let me share my
I
screen.
think you were
Huh?
building the, I think the previous error was not for this project. It was for A1 test. Because if you see A1 test, there was
Okay.
some problem that you didn't fix.
Yeah, it's because I kind of copied it down again because I was trying to do this file in here.
Because you have two main.
This
You
folder.
don't you shouldn't have two main in the same project. That's why
Oh, okay.
you cannot have two main functions with C or C++ project. Or even C#.
Okay, I thought we could have. Okay. I'll share my screen right now. Or
Okay.
show my camera.
Okay. Perfect.
Thank you.
Hey, Professor.
Yes, Genesis. Yeah.
Can I share my screen and can you help me out real
Of
quick?
course. Of course.
So, can you help me out with the driver lib again? Oh,
Yeah, just go. No.
properties.
Just cancel. Yeah, cancel. No, right click on the project name itself. Lab2 GB. Yeah, this guy. Properties. Yeah. Then include options. It's in the middle of the left hand. And yes, include option. Yeah. Add. You see this plus, green plus? Yeah, add workspace. Lab2. No, no.
Oh.
Workspace again. Yeah.
Okay.
Yes. Driver lib. Again, driver lib. Yeah. It says, yeah, hit this guy. Okay. And apply and close. Is it now hammer? No, just, yeah, this, oh. Okay, oh, the hammer. This was, so the first main is the main of the first project, I think. So yeah, now hit the hammer. The hammer, yeah. Yeah, this guy. Yeah.
Whoa.
You have problems. Why this guy has problems?
Is it because of the main.c?
You have one main, so that shouldn't be a problem. Yeah, go to the first main. What does this mean? The first one. Yeah.
It's the first lab.
Yeah, just close it. Close it for now.
Then hammer again.
Maybe hit again. Yeah, hit again. It's something not good. Because what it says basically. Can you double click on the main.c? No. In the project explorer itself. Yeah. Double click. It is this. That's fine. Let's redo this again and from project itself.
So should I make a new project?
No, just hit, click on that guy.
Mhm.
Then go to project menu. Beside there in the top left.
Project menu.
Yeah, there is a project. File, edit, view, navigate.
Mm.
Yeah, go. Yeah, go no. Go to the right. Go to the right. Yeah, continue until you hit project. Continue again.
Ah.
Yeah, properties. Choose properties. It should be there. I don't know why it's not. But let me add again. Let's do it again.
Mhm.
Add workspace, lab 2, driver lab again. This guy. Hey, can you open it? No.
Yeah.
Maybe the file is not there. Can you no? Hey, yeah. Okay, that's good. Okay again. Apply and close. Hit the hammer. If it doesn't work, create a new project. Like the first time. It doesn't look. Create a new project. Okay.
Mhm.
And you have 2 folders. I don't know why you have 2 folders, but just copy and paste the folder that's called driver lib, in which in which there is another folder which is MSP whatever. Okay.
Okay.
Don't avoid that mess. You can even delete this one.
Delete
it
this one?
completely. Yeah, completely delete it.
Okay, delete that one and then
From file. Yeah.
file,
New
new project.
CCS project. Then yeah, choose here series. No, I think family, not series. No, family. Yeah, family. Then R. The one with R. MSP432. Yeah, this
Then this one.
project name. Call it A2 test. I have some A2 underscore test or A2 only, whatever.
Mhm.
Then empty project. There should be what? There should be a finish. Why it's not accepting that? Because the first one is called the A2 as well.
Ah.
You have
Okay.
yeah. So call it call it instead of test, call it GPIO. GPIO cheap A2 or whatever. Okay. Underscore lid one. Yeah. Finish. Now just delete all of this and copy and paste or write it. That's fine.
Okay, I think I gotta write it again.
You don't
but-
have to write it all. Just write, for example, look at my screen. I will share my screen. I'm sorry.
Mhm.
I will stop yours for a moment. Okay, let me share mine now. So, write until here, then exclude all of this and write, because if you have a problem with driver lib, that line will show a problem. You understand?
Okay.
Just to know where is the problem exactly.
So
Mr. Mustafa,
Yes.
am I able to share my code and show you the robot?
Okay.
Let me share my screen. So this is my lab 2 folder, and it has the main. I call it lab 2 main, and I think everything runs if I just click the hammer and then the debug. So I'll just show you the
Okay.
robot now. Are you able to see it, or?
No. Stop sharing. We'll stop. Okay. Thank you.
And this was just for port 1, right? We have to do port 2 on our own.
Yeah, I will publish this assignment today after the lab.
Oh, okay. Thank you, Mr. Mustafa.
Thank you very much.
Professor, can I share my screen real quick?
Yeah.
So from here, Professor, I should just copy driver lib.
It's working. Yeah. Okay. Yeah.
And
No. Go to the driver. Go to the folder called A2 test. This A2 test is the first project. It's actually a folder in your computer.
Mhm.
Just go to it, and I will let you know what to do exactly.
Okay. 1 second.
Dr. Mustafa,
Yes, Clark.
do you want LED 2 to be? Do you want us to show you LED 2 or just the LED 1?
Just
blinking?
lead one. Just
Oh,
lead
okay. Okay, I can show you that one then.
one. Okay.
I'll stop sharing my screen real quick.
Okay.
If we finish LED 2, do we also show you that right now? Or
No, because I want you. I want in a specific order for the colors that I will publish.
oh, okay. I was just having it blink right now. I thought you wanted LED 2.
Okay. Okay.
My
Thank you.
bad.
So, Professor,
Okay. Let's see. Okay, Clark. Thank you very much. Thank you. Thank you very much. Okay. Yeah. You are. Yeah. Yeah. Open it. Open it. Copy this. Copy this.
Okay.
No. Go. Yeah. Copy this.
copy
Copy.
this one. Okay.
Go now to GPIO LED folder.
Mhm. Then paste it.
Paste. Yes. Yeah. Now go right click on GPIO LED 1. Yeah. Properties. Add. Workspace. GPIO LED. Driver lib. Yeah. Hit this guy. Okay. Okay again.
There.
Apply and close. And hammer. There is a bigger problem you have.
Yeah.
I don't know why. But anyways. Can you expand these errors? Expand it. Expand it.
Expand it.
Go to the error. Yeah, expand it. Yes. Yeah, you have a problem with driver lib. Do the first project was working? I think yes, right?
Yeah, the first project we got it to work.
Where it
yeah.
is? This guy, right?
Mhm.
Okay, go to this guy and debug it. I mean, click the hammer for it. Yeah. Okay. Now what I want to do now, go to the project folder A2 test and copy and paste this folder, the folder itself. Copy and paste the folder. No. Go to the Windows. Yeah.
Right here.
Yeah, from Windows. Yes.
This A2
Yes.
test.
Copy it and call it whatever. Call it whatever. You know. Copy.
Copy it, then paste it right here.
No. Paste it in the folder. The same. This folder.
Okay.
Call it whatever. Call it. You know.
Rename GPIO.
LED 1. You know. Part 2. Whatever. Version 2. Something like this. Okay. Yeah. Now close the Composer Studio. Close the Composer Studio. Yeah. And open it again. It should pop up as a new project. Launch. Yeah.
Launch this one, Professor?
Do you have a workspace there?
A1.
Ah. So okay, I understand now because that's the issue that you have. Okay, choose A1 test.
A1 test, okay.
Doesn't show the second one, which is bad. No, close again. You have some problems with the workspace itself. I understand now.
Okay.
So can you Yeah, yeah. Enlarge this one. Let me see the folder itself. So look, Genesis, the meaning of workspace is actually the folder that contains all the project folders, all the projects that you have.
Okay.
So when I say A1 test as a project, as a workspace, is different from the project. A1 test as a workspace, that means that you created or you defined a workspace, a folder on your computer that will contain from now on all the projects that you're gonna implement. So if you create, for example, a project called the project 1 and another project called the project 2, both of them will be located inside a folder called A1 test. Okay, so that's why I think that the problem now.
Okay.
So what's we gonna do? What we gonna do?
Should I just transfer everything into workspace, Professor? And just
Maybe, yeah, maybe something.
Okay.
Yeah, let us see.
So if I go to workspace,
Expand this window. Expand it. Yeah. I know this. Go to window. There is a reset view, something like this. Appearance, or yeah, appearance. No, not this one. Editor, there is something called the reset view to make your view like others. The default one. Yes, this guy. Not this guy.
oh, not this guy. Okay.
Navigation. Try to click the hammer. Try to click the hammer. It's not working because you are not choosing anything. Oh, okay, good. Go to file. Switch workspace. Yeah, you have many of them.
Yeah. Should I just delete everything, Professor, and just
Yes, yes.
So delete this one.
So this is Dominique. Okay, Dominique, thank you very much. You can go, man. Okay, launch is this one. That's fine. Okay, expand the screen. New, file new, CCS. Oh, you don't have. Why you are different, my friend?
I don't know. That's why I
Project.
appreciate you helping me because I was trying to follow along, but then I came up to these errors.
Code Composer Studio. Code, yeah, this one. Yeah, good.
So then this one is going to be family with the R.
Choose any name. Test one. Let's go from scratch. Test one.
Yeah, okay. Test one.
Finish.
Finish it.
Okay. Now copy and paste. First, go to the project folder. We have a project now called Test One in Workspace version 10.
Okay.
Go to the folder. Go from Windows.
So if I type in Workspace or Test One.
It is somewhere. I don't know.
No.
Professor?
Yes, Alan.
Do you want to look at mine?
Yeah, of course.
Let me share my screen.
No, just the
robot is good.
Yeah,
Right, give me a second.
Okay, thank you very much. Thank you.
Okay.
Look, search on the internet how to reset the view, something like this. But not now, not now. Let's see now where is your, okay, we want to know where is your, so file, go to file, go to file. There is a, no, go to file. Yeah, switch workspace, switch workspace, the third, yeah. No, just, okay. So search inside ECE 4570. It's not there. That's very bad. I don't know. No, it should be there. Go again to file. I'm very sorry. Go again to file. That's it. Other. Choose other. Yeah, it's in users. Gmang or whatever this Gmang or Gmang. Yeah, this guy. Okay, yeah, finally, good. Test one. Here is test one. Now you keep this open. Go to whatever workspace you have before and copy driver lib and paste it in here. Yeah, close this. We don't need it. Go keep this window open. Now go to another window. No, keep this open. Keep this open. I don't know how to do new window. Yeah. Go copy a driver lib. Yes. Get driver lib and put folder and put it in that one. Copy. No, copy. Yeah, paste it in here. Good. Now go back to this guy. We should show the project is explore. I don't know why. Where is it? Window. I think it's in window. We can show it in window. No, editor. Maybe editor. Not editor. Go appearance. Project explore. Show view. I don't know. Show view. It's not there also. Perspective maybe. No, navigation. What it is called? Project Explorer. Show system menu maybe. Show system menu maybe. No, it's not. Maybe no, that's a new project. Yeah. Let me search for you. Let me search for you how to show project or search it yourself on Google. Studio. Yeah. You see that? You see my screen? Yeah, I got it. Try to follow that guy. This is a question, maybe.
Hey, Professor.
Yeah. Oh,
I
good.
got this kind of to open up, but is it local? No.
This is not Project Explorer.
Yeah.
But it should be there. Yeah, yeah. It should be there. Maybe. Something should show it. Maybe if you create another
I don't know what I just did. Now my screen's just blank.
Oh, good.
Okay, cool. So
Yeah.
can I just delete this A1 test, Professor?
Okay, delete it.
Okay. So right here, then
Now
from
right click
here,
on them.
properties, include options, add the driver lib. Okay,
Apply and close.
apply and close.
Hit the hammer.
Ah, no errors.
Nah, but we didn't add anything that use driver lib. So now add this B1 direction stuff, you know.
Okay, okay. Let me go do that, then I'll go share my screen afterwards.
Okay.
Thanks, Professor.
Professor, I'm having this same trouble.
Okay, share your screen. The TV is loud, my friends.
Sorry, it's my son.
That's bad. Okay, what is the problem?
So I'm getting this error, and I did everything the same. I remade A1 test because it wasn't working the first time, so I deleted everything and redid it, and
Okay.
and then I built it and then debugged it, and I'm getting this error.
No, because once it's not building or you have some problems or errors in the build itself, the debug will not work. So let's, I think it's a driver lib has a problem. So let's redo the same steps. Can you open this file? Yeah, open it. Click the arrow. Open this again. Okay, now just unexpand it. Collapse, yeah. Right click on A1 test. Right click. Yes, yes. Properties. Remove this one. Remove.
Remove. How do I remove?
The red.
Oh, right here.
Yeah, this guy. Add. Add.
Oh yeah, add.
Workspace.
Wait. Driver lib, and then click on this, right?
Yes. Okay.
And then apply. And then same thing.
It's still. Oh, okay. No, cancel. Go back, my friend. Go back.
How do I go back?
Do the bug again. Do the bug again. No.
Okay.
Let's the bug. Leave it to proceed. Okay.
Okay.
Yeah. Okay. I think. Can you expand the errors?
Oh, these?
Yeah, expand it. Hit the arrow. Can't
MSP dot.
include it. Yeah. Can you check if you have already this folder copied in the folder itself of the folder of the project?
Well, where would I go?
Go to your Windows and search for there is a project on your Windows called A1_test.
Oh,
File.
right here, A1_test.
Yeah.
You want me to click on it?
I can't see it. I can't see. You are sharing only. You are not sharing the screen. You are sharing the
right.
application only. Yeah. Yes. Open that guy. Open driver lib. Open that guy. So everything is fine. Now go back. Go back to A1 test. Go to Composer Studio. We're gonna check something. Composer Studio. The software itself is the program. You are sharing the
Same thing.
application. Yeah. Share the screen. Okay, so good. What we're gonna do with this? That's bad. Open this file. You see this last file called the system_MSP. Yeah, double click. Yeah, go down. Okay, close it. Nothing is there. No, close from the yeah. So what is the problem exactly? File. Switch space. The third option from the yeah. Okay, so this guy has okay.
Oh, maybe it's because it's still on the OneDrive.
I think you guys have a problem with the workspace. So your workspace now is called users Gustavo workspace_v10. Okay, A1 test. So go to users Gustavo the last one. Yeah. Hit that. Your screen just disappeared.
Yeah, let me
So what I want you to do now, you are now in okay.
I'm sorry, 1 second.
That's fine. So create a new project. I mean I'm very sorry for this, but do that from here. And now you know that you are working inside the workspace in users Gustavo. I don't what is it called? Something called _10, something like this.
Okay, sorry. Kids were fighting. I'm back. I didn't hear you earlier. I'm so sorry.
That's fine. So I want you to work on that workspace. Okay. It's called workspace_v10. Okay. So create the project there. Create a project. Delete this guy. Delete A1 test. Delete this.
Delete it.
Yeah, okay. Just delete. Now file, new, CCC. Yeah, this guy. Yes. No, the drop-down menu. Go to the drop-down menu. Hit that guy. Family. Yes. Then R. Yeah, that's right. Call it A1 test. Oh no, call it something different now. Call it, for example, test one.
All right, test one.
Finish. Okay. Now try to build that guy. Build it from the hammer. Hit the hammer. Yeah. This thing. Okay. Good. We are on a clean stage right now. So now I want you to go to the folder called. Hit file again. Hit file. Workspaces or workspace. Yeah.
This one.
Oh yeah. Don't choose anything. Okay. So your workspace is called C users Gustavo workspace_v10. That's your workspace right now. Not one of these. Okay.
Right.
So go to the folder called users Gustavo Workspace version 10.
So
Go
go
that
to
on the
that.
Windows. On the Windows, yeah.
Okay. Let me find it. User Gustavo Workspace. Okay.
Hey, Professor.
Yes, Genesis.
Can you see my camera?
Yeah, I can see you.
Oh, okay. I don't know how to flip the camera, but can you see this? Is that supposed to be right?
Is it working?
Yeah,
Yeah,
it's
yeah, that's
LED one just blinking.
okay. So Omar also is working, right? You are okay, Omar. Okay, thank you very much. Thank you.
Okay, Professor, I'm gonna share this part.
Just 1 minute, Gustav, 1 minute.
Oh, okay.
Oh, 1 second, not 1 minute. Okay. Yes, Gustavo, yeah.
Okay, so let me. Where is it? Where is it?
You are not sharing your screen, right?
Okay. So I'm here now. I'm at the location.
Yeah,
I'm at.
okay.
All right.
Yeah, go to test 1.
Test 1. Okay.
Yeah, good. So keep that open. Now get the driver library folder and put it in that folder. Keep that open. Go for another, you know, Explorer. Yeah.
Oh, okay. So then. Oh, you know what? I think I already have it downloaded. Downloads.
Go get it and put it, paste it in that folder.
Right. You know what? Should be. Where is it? Where is it? Okay. Put it in the A1 folder.
Yeah, put it in that for test 1 folder. Yeah, put it here.
Okay.
Paste it.
It won't let me do it unless I stop screen sharing. Come on. Okay, there. Now I did
I
that.
can't see your screen. I can't see it. Are you
Uh,
sharing your screen or?
no, it wouldn't let me, but now I'm gonna do it. Okay, so I have it right here, driver.
Open it. Open it.
Okay.
Open that guy to be sure that, yeah, okay, the files are there. So go back to test 1. Yeah. Okay, now go to the go to the Composer Studio. Okay, go to the Composer Studio.
Okay.
I can't see it again.
Oop, let me okay.
Yeah. Now remove that line out there. This line WT. No. Control Z.
whoops.
Control Z. Control Z.
How do I go back?
Control Z. Just print Control and the letter Z.
Oh, control and then.
Yeah. Yes.
Okay.
Okay. Remove that line called watchdog timer WDT. This line, just remove. Yeah.
This one.
Remove it. Yes. And add the first line. You see this line here in my code? You see my screen?
No, but I can look at it real quick. Why isn't it letting me? It's so weird.
You can see my screen or not?
No, I cannot right now.
So I'm sharing it right now. You should be able to see it.
Okay, I can see now. I had to stop screen sharing.
So, okay. So add this line
Include driver
before,
lift.
and before main. And only add this line. Don't include all of this line, just this line to test if the driver lib is working or not.
Right.
And please share your screen.
Okay, so it is include
Add
driver.
them, then share your screen. Add them first,
Right.
then share.
Driver lib.h.
Professor?
Yes, Genesis, you can go.
I can go? Okay, sweet. All right, thanks, Professor.
Omar also can go if he.
Okay.
Okay, now, yeah, remove the first line, include MSP.h. Yeah, remove that guy. We don't need it. Then go, yeah, P1, P capital.
P1.
Then dash, like minus, whatever.
Dash.
Yeah, dire. Yeah, that choose, yeah, dire. The first option.
This one?
Yeah, yes. That's very neat. Yeah, equal to 1.
Equal to 1.
Semicolon.
Okay.
Now, expand is in the project explorer. Expand is a project. Yeah. Now, project. Right click. Yeah. Okay. Properties. Yes. Include options. Include options. Add.
Right.
No. You press that. Add. Yes. Add. Workspace. A1 test. Driver lib. Yeah. This guy. Hit it. Yeah. Okay. Apply and close. Yeah. Then hit the hammer. Very nice. Now include all the other lines. So you see my code, add all the other lines.
Okay.
Add all the other line. Now you should have no problem.
All right, let's check it out. I'm gonna stop screen sharing so I can see your code.
Okay, that's fine.
Okay, I think I got it. Now,
Good.
share my screen. Save all. It looks like it's right.
Yeah. Just show me the. No, it's not right because you forgot the OR, the XOR stuff.
Oh,
This XOR stuff.
let me see it.
You see this?
Oh,
this?
yeah. I see it. I see it. Oh, man.
That's very nice because that's why if you write it by, you will discover many problems.
Yeah.
Okay?
Okay, I think.
If your LED is blinking, just show me the, open the camera and show me the.
Okay, so now I can save it, hit the hammer, and debug. Okay. Yeah, it's
Is it blinking?
yeah, it's
Should
blinking.
be. Show me. Open your camera, whatever. Okay, my friend. It's not blinking.
But it was blinking, but it just stopped.
Okay, go back to the code. You still have a problem. Back to the code. Show me your screen.
Include driver lib.h. Is there something wrong with
Hit the green arrow. It's just stopped. Yeah.
Oh,
It should be blinking.
oh, there it is. It's blinking. Wow.
Okay.
It's really good.
Show me. Thank you.
All
That's
right.
it, my friend.
Thank you so much. I appreciate your help.
Thank you. Yeah, thank you very much.
Thank you. Thank you.
Okay. Have a good day. Bye bye.
All right. All right. You too, Professor. Thank you.